Hello everyone. Today's topic is trees. We are going to discuss what are the trees, what are its application and what are its type in today's video. So let's start with the trees. So first of all I would like to tell you that DSA is stand for the data structure and an algorithm, and trees is the one of the most important topic in it. So what are the trees? First of all I would like to draw an example of a tree, and with the help of that I will explain you what we are going to discuss today. This is a simplest example of the tree. If I would like to draw further, I can do the same D, E and the F and the keep going on. This is called a tree. Okay. When we are going to study about the trees, it is very important to first of all discuss some of its terminologies. There are some of the terminologies which we have to study. The first one is root. What is a root? As you can see, this tree is starting from this node. Okay, so the here for this tree, the root is the A. Okay. Second, parent, then the child, then the sibling. As we draw the family tree in the in our childhood, so what we keep the pictures of our parents, then the child's, then their child, then keep going on. The tree keeps keep going downwards. Okay, same that these trees work. This node is root node, and the further the parent nodes. What are the parent nodes? The nodes which connects to the child. The nodes which connects to the child. Okay. Such like the C. C is a parent of D and the E node. Okay. And similarly the B. B is also a node. This is a parent node. Okay. And who's this child? The F is child. F is the child of B, and A is the root node or the parent node of the B and C both. Okay, root node for the whole tree and the parent node for the B and the C only. Okay, next, child. Similarly, the childs which are connected, the nodes which are connected to the parent nodes are called the child nodes, like the D and E and F also. Okay. What are the siblings? Just like in our family, our parents, our siblings, such that the siblings of the nodes are there. A is the parent of both the B and the C. So B and C are the siblings to the each other. Acha. Then D and E are the siblings and the C is the parent node of both the D and E. So D and E are also the siblings of each other. Okay, next, the degree of node. This is something important is there. Degree of node. What do you mean by degree of node? What about that? Degree of node is nothing but the number of the direct children. The number of direct children. If we take the example of A, so the degree of node A is 2, as A has the two childs, B and the C. If we take the example of the B, what is the degree of B? Degree of B. What's the degree of B? The degree of B is 1. Why? Because there is only the one direct child of the B, and degree of C is 2. Because C has two direct children, D and the E. I hope you will understand this concept. And now the further the degree of the tree. Degree of tree. I would like to tell you that the degree of a tree is already predefined. Okay, it is predefined. And next, the level. For further, I hope you will understand till here. Now I have to rub this. So I will write level and the height. These two are both the different terminologies of the tree, but I will explain you side by side. Okay, if it start about the with the level. What is the level of this tree? The level of the tree will be started from the 1. So here is the level 1, here is the level 2, and this is the level 3. Okay, the tree may be the further keep going on, then the level number is also keep incrementing. Okay, but what about the height? The height of a tree will start it from the 0, not by the 1. So what's the height of the tree here? 0. Then what's the height here? 1, 2, keep going on. So here's the concept about the level and the height of the tree. So, okay, then there come the next, internal nodes and the external nodes. First of all, we will read about the internal nodes. What are the internal nodes? Internal nodes are also known as the non-leaf nodes. Why? Because, and what are these leaf nodes? Okay, first of all we will learn about the leaf nodes. What are the leaf nodes? The nodes which do not have their child. The nodes which do not have their further childs are called the, or we can say that which are not the parent node, are called the leaf nodes. If we take the example of E, D, here what's the, is there any further link? No, they don't have any further link to their child. They don't have any further classification in their child. So D and E are called the leaf nodes. Okay, and these leaf nodes are called the external nodes. So I hope you understand what are the internal nodes. Yeah, the nodes which are the non-leaf nodes which have their further classification in their child are known as the internal nodes, like B, C, and the A also. A is also an internal node. B is also an internal node because B has the one child, F, C have the two child, D and E. So these are called the internal nodes, and F, D and E are the external nodes, are the leaf nodes. Okay. The two terminologies which we need to study as ancestors. What are the ancestors? What are the ancestors? So if I would like to explain the concept of ancestor, I can say that if I start moving from the E, okay, and keep going upward direction, keep moving in the upward direction, E has the parent C, C has the parent A. Just like our family, if D and E are us, okay, C is our parent and C's parent, that means our grandparents, is A. So ancestors are E to C. I will draw in the upward direction only. Okay, so E is here, then the C is here, after C the A is here. So these are the ancestors. Okay. Descendants. So what are the descendants? The opposite of ancestors. If in this we move from the upward to downward direction. First of all A to B, then the B to F. Okay, so sorry, A to B and B to F. This is called the descendants, and this is are called the ancestors. Okay, we are till now we have studied some 10 to 11 important terminologies of the trees, which we keep studying in the further classes also. These are the we have many other terminologies regarding the trees, but these are the main and the basic terminologies of the tree. Okay, so next, what are the applications of tree? We have studied the trees, what are its, how it works, and but now we need to study what are the uses of these trees, where we can use the, which is called the applications of tree. So what are the applications of tree? First of all, to represent the hierarchical status of the data. Yeah, all the data which is stored is only in the forms of the trees and graphs only. Okay, so this is the main basic main features of the tree. To represent the hierarchical data, where we can represent okay, in the organizations, where with the help of Excel sheets, B and B++, these all are the uses. Okay, and next, the binary search trees, where we can use these trees, the binary search trees, binary heap, and the next one is HTML content. In these all are the applications of the trees. So we will start with the binary search tree. Okay, now we are going to study what is the binary tree. This is the most important topic in the trees, that how we will study that how the binary tree work, what are its logics, and what we how we can access through it, how we can access the data through binary tree. So concept is binary tree. So what is a binary tree? The tree which have the at most 2 children for all the nodes is called a binary tree. Tree having at most 2 children for every node is called the binary tree. What is the example of a binary tree? This is a example of a binary tree. Okay, why it is a binary tree? Because every node has the 2 children. Okay, this the parent node or the root node having the 2 children, this and this, B and C, and the C has the further 2 children, D and E. So this is example of binary tree. Okay, this is a binary tree? Yes, this is a binary tree. Why? Because at most 2 children, every node should have at most 2 children, not more than the 2, but less than the 2 can be possible. It means a node which can have 0, a 1 and a 2 child at a time. Okay, so this is called the binary tree. It means this node 1 has the only one single child 2, only single child 2. So it is an example of binary tree. Okay, now I would like to draw further one more binary tree. You will tell me whether it is a binary tree or not. 1, 2, 3, 4, 5 and the 6. Is this a binary tree? No, this is not a binary tree. Why? Because 1 has the 2 children, 2 and 3, okay, satisfying the condition. Okay, we will 2 have no children, okay, satisfying the condition. Maybe possible to, don't, it is a leaf node, it is an external node. Okay, but if we move to the 3 have the 3 children 4, 5 and the 6, which is not possible. 3 is not allowed. So this is not a binary tree. Okay, I hope you will understand this concept, and I will keep moving ahead and towards next topic, that is the okay. What is this L skewness, R skewness? What does L and R represent? What the term skewness means? The skewness means single, as like you and me. Skewness means the single. What do you mean? The single side. If okay, I will draw a binary tree, then I will explain. This is a parent node, child. This is the example of L skewness. L is left. Okay, yani ki left skewness. Only the left side of a tree keep moving on. Okay, this parent node doesn't have any second child and only have the single child, and this child also have only one child, and the tree is keep moving downwards. If I will draw a tree like this, this is the example of L skewness. R means sorry, R skewness. R represent is right, because it is moving only in the single direction, right. So I hope you understand this concept, L skewness and the R skewness. What do you mean? And for this we have a formula. Okay, now it come to the some logical part, more logical part. Formula. If I said to you that you have to draw a tree having the 3 nodes, okay, so you can draw in a very different manners. You can draw like this. Okay, yeah, this tree also has the only 3 nodes. You can draw like this. Yeah, this tree also have the 3 nodes. You can draw like this. There are the many ways to draw a tree. Okay, so how we can calculate for the how many number of nodes, what the number of designs of the tree we can draw. So for that we have a one formula, and what the formula is, Catlin formula. The formula is Catlin formula. This formula is 2n Cn upon में n plus 1. Okay, this is a Catlin formula. This formula gives the number of the trees which can be formed for the given number of the nodes. This formula, what we get from this formula, this gives the number of trees which can be made for given number of nodes. Okay, so now you can calculate with the help of this formula. If I told you to draw a tree, all the possible patterns of the tree for the tree having the number of nodes equals to 10, you can just simply put the value of n in this, and you will get the number of trees pattern. So this is the formula for that. Now the next important topic is height versus nodes. We are not going to perform any fight in between them. We are just comparing. What we are comparing, if the height is given, then the how many nodes will be in the tree, or in the number of nodes in given, then how we can calculate the maximum height of the tree, the minimum height of the tree. We are going to discuss about here. Height versus nodes. Okay, and these all things are coming under the binary tree. We are learning this concept for the binary tree. Further we will again study the same concept but for the strict binary. Then the different further that we will study again this for the next different type of tree. Okay, so one thing you keep in mind that this concept is running for the binary tree right now. Okay, so first point, first condition, when the height is given and find the number of nodes. First condition is height is given and find the number of nodes. Okay, so how we can calculate? If I, for example, if I draw like this, so what's the height of for this tree? Yeah, height is start from 0 and the 1, so height is 1. Okay, so for the height 1, how many number of nodes are there? Number of nodes are 2. Okay, if I draw another tree like this, so what's the height here? 0 and the 1. Again the height is same 1, but now the number of nodes are 1, 2 and the 3. The number of nodes are 3. One thing is clear from here that for the same number of height we can have different number of nodes in our binary tree. Here's the example. The height is same in both the cases. Height is 1, height is 1. But in this case the number of nodes are the 2 only, and in this case number of the nodes are 3. So we call this simply as the minimum number of nodes, and for this we can get the maximum number of nodes. Why we call this maximum? Why cannot be there is the further childs? Yeah, I hope you understand. No, this is not possible because we are learning about the binary tree and we have studied that only the 0, 1 and the 2 number of nodes can be possible for a given number of for a particular node. Okay, so this parent node only can possible number of nodes are 1 and 2. Okay, so that's why it is called the maximum number of nodes and this is called the minimum number of node. Okay, for this we should derive a formula. Okay, what's the formula for this? For the minimum number of nodes, for this minimum number of nodes n equals to what we are getting. If the height is 1, if the height is 1, how many nodes are there? 2. Okay, so we simply can say that if the minimum number of nodes n equals to h plus 1, this is the formula for minimum number of nodes. Okay, similarly for the maximum number of nodes, what we are getting? The formula, I will rub it, otherwise you can get confused. Okay, yeah, for the maximum number of nodes the formula is h to the power 2n plus 1. Oh sorry. For the maximum number of nodes, what the formula is? To the power h plus 1 minus 1. This is the formula you can get by simply just putting the number of put the value of h, you will get the number of nodes for the maximum nodes. That if the number height is this of a particular tree, yeah, not necessary that only the height is always 1. The height can be anything. If a tree is like this, so what's the height here? 0, 1, 2, 3 and the 4. So we have to just put the value of 4 as the h, and you will get the number of maximum nodes for this particular tree. Okay, what's the answer should be? 2 to the 4, 6, 8, 10 and the 11. Answer should be 11. You can check by putting the value here. Okay, This was our first case. I hope you have write it down. The next is second condition, second case, that if the number of nodes are given and we have to find the height. Second case is number of nodes is given and find the height of the tree. Then how we are going to calculate the height? Okay, for that also we have the formula. I will you can take any example of the tree. Okay, we simply for the minimum height, what should be the minimum height, and h ले लेते हैं उसको h, and what should be the maximum height, h. So what's the formula will be? For the maximum height, the formula is n minus 1. Okay, and for the minimum height, the formula will be log to the base 2 n plus 1 minus 1. This will be the formula for the minimum height and the maximum height. One thing you I think you should notice that the formula for the minimum number of nodes in this case is equal to the formula of the number of maximum height in this case. The sign is also changed. Okay, now this concept is completed here, height versus the nodes. We have learned about the two cases. When the height is given, then how we can find the number of nodes in a tree, and the second case we have discussed the number of nodes is the given and how to find the height of the tree, and for the formula for the minimum and the maximum number of height, and what the formula for the minimum number of nodes and the maximum number of nodes. Okay, so the next topic is internal nodes and the external nodes. Internal nodes versus external nodes. Okay, so we have already discussed what are the internal nodes, what are the external nodes. Okay, I hope you understand that concept. Again, I am drawing a particular tree. Okay, like this, having the two child, and this having the further two childs. Okay. A, B, C, D, E, F and G. I just label all them so we can easily get access to each and every node without any confusion. So we have already discussed what are the internal nodes. Okay, so if I ask you something that tell me how many nodes are present here which having the degree 2, having the degree 1 and the having the degree 0. What should be your answer? Yeah, what do you mean the degree? The number of direct connected child. ठीक है, A, if we start with the root node A having the 2 degree. Why? Because it is directly connected to the B and the C. A having is the parent of B and the C. So the degree of the to A is 2. Okay, let's come to the B. B is having the further two child D and E. So what will be the degree of the B? Degree of B is 2. Okay, next D. What's the degree? Does it have any further child? No. E having the further childs? Yes, F and G. E having the two childs. So the degree of E is 2. So how many number of nodes are there which having the degree 2 in this tree? Yeah, 1, 2 and 3. So what's the answer? 3. Okay, next let's come to the degree 1. How many nodes are there which having the degree 1? Let's take example. A we have already discussed, having the degree 2. B having the already discussed, what's the degree of B? 2. C, does the C have any single child? No, C is our leaf node. Okay, next come to the D having the further child? No. E having the further child? Yeah, but already we have discussed that E having the degree 2, not 1. So in this tree there is not even a single tree is there, a single node is there which having the degree 1. So the answer is 0. Okay, nothing. Next to the next one, degree 0. Let's check for the degree 0. What does the degree 0 mean? That the node which does not have any further child. We have to find out that. Okay, so A having the 2 childs. Okay, B and the C. Does C have any further child? No. So what's the degree of the C? Degree is 0. Okay, let's come to the D. Does D have any further child? No. So the degree of D is 0. Okay, and the F, oh sorry, E having the 2 childs. So the degree of the E is 2. F and G are the childs of E. Okay, let's come to the F and G. Does the F and G have the further child? No. So F also having the degree 0, G also having the degree 0. So how many number of nodes are there which having the degree 0? 1, 2, 3 and the 4. So the answer is 4. Okay, let's take one more example, then I will come to the formula point. Okay, I will have to draw a tree. If I draw a tree like this, then what will happen? Okay, let's draw 2 more. So here's the tree. Again, oops, sorry. Again I will do the labeling part. A, B, C, D, E, F, G, H, I. Okay, good. Next, again my question is same. We have to find the degree 2 number of nodes, degree 1 and the degree 0. Without wasting our time, we will find the number of nodes having the degree 2. A having the degree 2. Okay, one node is here. B having the degree 2, one node is here. C having the degree 1. Okay, came to the E is a leaf node. Next to the D having the degree 0. So one node is here. E is a leaf node. So how many number of nodes are there having the degree 2? 1, 2, 3. So answer is 3. Next, now the degree 1. How many nodes are there having the degree 1? Only the C having the F. Okay, so and the next one is F also having the only single child I. So how many number of nodes are there? One is this, one is this. So answer is 2. Okay, number of nodes having the degree 0. Number of nodes having the degree 0. So what are they? 1 node, 2, 3, 4. 4 nodes are there which do not have their further child. 4 nodes are there which do not have their further child. It means their degree is 0. So how many nodes are there? 4. Now let's come to the formula point. What's the formula? We will notice that the number of nodes having the degree 0 is 1 more than the number of nodes having the degree 2. Similarly, like this, the number of nodes having the degree 0 is 1 more than the number of nodes having the degree 2. So what will be the formula? The formula will degree 0 equals to में degree 2 plus 1. In our question, if the number of nodes will be given having the degree 2, then we can easily find out how many number of nodes having the degree 0 will be with this formula. Okay, so till here we have discussed what in today's video. What we have discussed what are the trees, we have discussed what are its important terminologies, and what are the heights, nodes, internal nodes, external. Well, these all are the terminologies, and we have studied the application of the trees, where these used, how we can access in with the with these nodes, how the data is stored in these. Okay, we have studied the types of the trees. First, in today we have studied the binary tree. In the next topic, in our next lecture, we will study or we will find out the how the binary tree work, and what are its type also. The next type is binary tree also has the further classification. Strict binary is there, we will learn about it in the further video. Okay, for today only I will stop my video here. I hope you understand the concept which I taught today. Thank you.